Hello everyone, for your convenience in understanding the instrument, we prepared this video to introduce ZR-1000 Mask Bacterial Filtration Efficiency Tester, BFE, and guide your operation. First, we'll introduce our instrument. ZR-1000 Mask Bacterial Filtration Efficiency Tester, BFE, can test the filtration efficiency by generating specific size and concentration bacterial aerosol and draw the aerosol into two-path Anderson samplers in specific flow rate. After well mixed in aerosol chamber, put the sample on one of Anderson samplers. The other one is positive control. The bacterial filtration efficiency of the mask is obtained by calculating test results of two groups. It is suitable for the performance test of medical mask manufacturers and related testing companies on the bacterial filtration efficiency of masks. The instrument is mainly composed of two parts. One is the mainframe box, and the other is bracket. After receiving the instrument, at least 4 personnel need to hold the handles of the mainframe and place the box on the bracket to fix it. No additional fixing device is needed. The mainframe box is composed of control panel and test chamber. The control panel is composed of USB port for us to export data, illumination system, ventilation system, UV disinfection system, and power switch. The internal structure of test chamber is mainly composed of the following parts. Peristaltic pump is to pump bacterial suspension to the nebulizer in specific set flow. Nebulizer will generate a specific concentration and size bacterial aerosol in specific spray flow. Aerosol will enter aerosol chamber and well mixed in it, then draw into 6-stage Anderson samplers through a sampling flow of 28.3 liters per minute. Before performing the experiment, some preparation work is required. First is the preparation of standard bacterial suspension. The strain needed here is Staphylococcus aureus, and the whole process should be performed in biosafety cabinet. Put the Staphylococcus aureus porcelain bead, finished product, into 100 mm stabilized Tipton broth. Dilute and culture with shaker for 24 hours to get original bacterial suspension. The experiment requires to confirm the concentration of original bacterial suspension, so we can use gradient dilution technique. Shake to make sure the suspension is well mixed, and then use a pipe type to take 1 mm of the original bacterial suspension and add it to 9 mm of tryptophan broth. Then take 1 mm of tenfold diluted broth into 9 mm of tryptophan broth, and repeat the same operation until diluted to 10 to the power of -8-fold. Mark the prepared TSA plate mediums. Take 1 mm of 10 to the power of -6, 10 to the power of -7, and 10 to the power of -8 bacterial suspensions, and add it into TSA dish. Spread the bacterial suspension evenly by spread rod, and notice to disinfect the rod by the alcohol burner. After finishing the spread of 3 concentrations, put the plate culture in incubator for 24 hours. After 24 hours of culture, take out the plate to count colonies. Each gradient is counted individually, and judge the tenfold relation according to 3 counting result. If they are, calculation formula is A divided by V and multiply D. A is average colony number on plates, V is incubation volume, D is dilution ratio. After the preparation of bacterial suspension and medium, we can start the experiment. First, open the door of the cabinet. Make sure all pipeline is connected correctly and no gas leakage. Put the experimental sterilized plate and pre-treated mask sample into the test cabinet. Put the test tube containing bacterial suspension and the wasted liquid tube on the rack. Put the peristaltic pump sucking tube into bacterial suspension, and put the wasted liquid discharge tube into wasted liquid tube. Close the glass door and start the experiment after checking. Connect the power supply and turn on the main switch in the bottom right of the bag. Long press 3 seconds to boot up. Turn on light and ventilation. Operators sit in front of the machine. Put hands into gloves. Disinfect gloves with alcohol cotton ball. Remove a sampler from any path. Open the clamp and put the sample into it after flatten. To make sure the sample is clamped completely, the area of samples should be larger than sampler head. Finally, clamp tightly and put it aside. And the sampler has 6 layers of samplers with different size apertures, representing 6 stages. From top to bottom, they are the first stage, the second stage, the third stage, the 6th stage. Do not mess up the order. First, gradually place empty samplers in reverse order, and then take a petri dish with agar medium number 6 and put it on the bottom sampler. Remove the lid of the petri dish and buckle it reversely on the table and place the 6th stage sampler on the bottom sampler. Then take a petri dish numbered 5 and put it on the 5th level sampler. Put all the 6 petri dishes into the sampler in turn. Then install the sampling head with the sample in the uppermost part, and hang the 3 spring hooks on the 3 fixing nuts on the sampler to fix the whole sampler. This group of samplers serves as a sampler test group. Take another sampler without placing test samples, and put 6 petri dishes into it in the same way as above. This group is regarded as the positive quality control group. Click Mask Task to enter the main test interface. Click Start Peristaltic Pump. Set the flow rate of the peristaltic pump to 300 mm. Click OK, and wait until the bacterial suspension flows along the liquid inlet hose to the spray nozzle of the nebulizer. About 3 seconds. Click Stop Peristaltic Pump on the interface. Click System Settings to set the peristaltic pump flow. Set according to the test report. The nebulizer flow is about 10 liters per minute. See the test report attached with the instrument for details. Sampling duration is 2 minutes. Liquid supply duration is 1 minute. Automatic clean duration is 1 minute. Click OK after setting. For more experience, click the Start Test button. The interface pops up the Start Gas Path Balance dialog box. Click OK. Each gas path of the equipment starts to work. Wait until the flow rate of each working pump in the interface data parameter dialog box reaches the set flow rate, and the negative pressure of the aerosol chamber reaches the requirement -90 to -100 Pascal. Click the Confirm button in the Start Formal Test dialog box on the interface to start the formal test. After sampling, the instrument automatically enters the post-sampling cleaning state, and when the post-sampling cleaning changes to the idle state, the self-cleaning is completed. At this time, the first group of sampling is completed. Unplug the sampler with the sample from the aerosol chamber. Remove the sampling head, but do not open the tested sample. Take out the petri dish and cover the lid, and put the second group of petri dish into the sampler in sequence. This operation is the same as before. And finally, the tested sample is removed from the sampling head and placed in a beaker containing 75% alcohol for soaking disinfection. Put the second sample into the sampling head and clamp tightly. Assemble the sampler and reconnect it to the aerosol chamber. Remove petri dishes in the sampler of the positive quality control group according to the same operation, and replace them with the second group of petri dishes. Repeat step 1, 2 until finish the 3 groups of sampling. After all the tests are finished, take out the petri dishes and other test tools in the cabinet. Then click Cross in the upper right corner. Click OK on the pop-up Exit Test Dialog box. Exit the test interface and return to the main interface. Click System Cleaning. Open the glass door and insert a test tube containing bacterial suspension and waste liquid tube with a stopper and replace them with a test tube containing 75% alcohol and a new waste tube. System Cleaning. Disinfectant Cleaning. The next step is to perform the system cleaning operation. Exchange the test tube containing the bacterial suspension with the test tube containing 75 alcohol. Click System Cleaning on the interface. Set the cleaning duration to 5 minutes and the flow rate of the peristaltic pump to 1 to 2 mm per minute. Select Disinfectant Cleaning and click OK on the pop-up Start. Disinfectant Cleaning dialog box. At this time, 75% alcohol enters to the aerosol chamber from the inlet hose to start cleaning the pipeline. After cleaning, open the glass door. If there are water droplets in the waste liquid outlet of the nebulizer, place a waste liquid cup at the bottom to drain the waste liquid, and then tighten it again after emptying. Take out the test tube containing alcohol, replace it with a test tube containing purified water, and close the glass door. Distilled water cleaning. First, click Clean with distilled water. Close the glass door. Repeat the above steps. Air cleaning. Click Air cleaning. The cleaning duration is determined by the residual liquid in the sprayer. This process needs to clean all the residual liquid in the pipeline. The liquid in the waste pipe can be ignored. After the cleaning is completed, click the cross in the upper right corner to exit the system cleaning system. Shut down. Click Shutdown System on the operation interface and click OK on the pop-up Shutdown System interface. Turn off the lighting and ventilation. Press the red on or off switch on the panel for more than 2 seconds, and the red switch on the front panel will off at this time. Turn on the UV lamp for disinfection. The disinfection duration can be determined according to the actual situation. After the disinfection is completed, disconnect the instrument to power supply. Finally, wipe the inside of the cabinet and rubber gloves with the disinfectant. Remove the sampler and the hoses connected up and down. Wipe the Anderson sampler with alcohol, and then bake it on the alcohol lamp to remove the cotton wool sticking to the sampling apertures. If the apertures are blocked, open it with a needle. Rinse and disinfect the hoses with 75% alcohol. Place the sampled petri dish in the incubator for 24 hours. Take it out and count the number of colonies. Positive quality control value calculation. Count the number of the colonies in each layer of the positive quality control group. Convert the count result, R, into the corrected particle count value, P, according to the positive aperture conversion table attached to the standard, and sum all p-value, then the positive quality control value is obtained. The two groups of positive quality control values are averaged to obtain the final value C, which is 2200 plus or minus 500 CFU. At this time, the experimental data can be determined to be valid. If it does not meet the requirements, the experiment should be performed again after the concentration of the bacterial suspension and the nebulization method were modified. Bacterial filtration efficiency calculation. Count the number of colonies in each layer of the experimental group. Convert the count result R into the corrected particle count value P according to the positive aperture conversion table attached to the standard, and sum all p-value to get base value T. Calculate the bacterial filtration efficiency according to the following formula. BFE equals bracket C minus T bracket divide C times 100%. In the formula, BFE is bacterial filtration efficiency. C is the average value of positive quality control. the sum of the number of colonies in the two positive quality control groups. Divide 2. Calculate the average value. T is the sum of counts of bacterial colonies in each group of test samples. What's the reason for a positive quality control value of ZR-1000 Bacterial Filtration Efficiency Tester does not comply to required standard range? 202,000 plus or minus 500 CFU. Bacteria suspension doesn't meet requirements of national standard. The flow rate of peristaltic pump is not optimal. Try to increase or decrease flow rate. Check the size of petri dishes, especially glass dishes. What's the reason for other bacteria grow after sampling by ZR-1000 Bacterial Filtration Efficiency Tester? The pipeline is leaking. Check whether the silicon connecting pipe on the glass is leaking. The environment is not aseptic when preparing the culture medium. The work environment is harsh, or the HEPA filter fails. Check the size of petri dishes, especially glass dishes. How to fix the problem that the ZR-1000 Bacterial Filtration Efficiency Tester BFE can't boot up. After pressing power button, the red power light doesn't work. Lamp and UV light also don't work. Check whether the power line is connected and there is power supply. And check whether the leakage protection switch at the back of the instrument is turned on. The power indicating light is on. Lamp and UV light also work, but the screen is black and the machine can't boot up. Disconnect to power supply. Boot up again and tap the reset button on the front panel. The parallelism problem of A-B two-path Anderson sampler in ZR-1000 Bacterial Filtration Efficiency Tester BFE. The sampling result of A and B two-path is different. Check whether the flow rate of A and B is consistent. Check whether the pipeline is leaking, and check whether the size of the petri dish is suitable, especially the glass petri dish. If the petri dish is too high, it will jack up the upper layer, which will cause the Anderson sampler to leak. Check whether the apertures of each Anderson sampler is blocked. Simple test method. Visual observation. If blocked, clean it before testing. The embedded thermal printer can print test results automatically. The guidance of operation is finished. Thank you.